Okay guys, let's proceed with the next example. So we're left with two examples, but I'm just going to discuss up until example 3, and I hope you can try to do on your own for example 4. Okay, because I already guide with 3 examples, and I really hope that you can do this one. So and end up with this answer. Okay, so PQ here, as you can see, I'm using PQ here. This is just AB. Okay, A plus B. Okay, P as A, Q as B. You can use any constant that you want. Okay, so I'm using P and Q here. Okay, so example 3, you were asked to find the general solution for y double prime plus y is equals to secant x. So as you can see here, your function on your right hand side is one of the function that we discussed earlier in the definition, whereby your fx is in terms of secant or cotangent or tangent. You cannot use UC to solve it. Okay, you have to use VOP. Okay, so this one here, you cannot use UC case 3. Okay, UC case 3 is just for cos and sine function. Okay, so that's why we're using VOP. So the first step is to get your YH by assuming fx is equals to 0. I am pretty sure up until now you already remember your solution for YH when you have a different root, equal root, or complex root, because we keep on using that solution till the end of the chapter. Okay, so I hope right now you don't have any problem to get your YH. Okay, so by assuming fx is equals to 0, so you have y double prime plus y is equals to 0. So change this one into characteristic equation, will give you m squared plus 1 is equals to 0. Okay, so if you use your calculator when you substitute your value for a, b and c, you will have I here. Okay, so this one refer to your beta. Okay, so you don't have alpha value, isn't it? You just have beta value because you have I here. Okay, so therefore your m is equals to plus minus I. Okay, so generally this is case 3, which is complex root, where the general is m is equals to alpha plus minus beta I. So by comparing with the value of m that you get, so you know that your alpha is equals to 0, because you don't have anything in front here, and your beta is equals to 1, the coefficient of I. Okay, so your beta is equals to 1. Okay, so therefore your general solution will be YH is equals to A cos x plus B sin x. Okay, we don't have the exponent function in front here, since your alpha is equals to 0, E0 is equals to 1. So therefore you left with this one. Okay, so now proceed to the next one. Identify your y1 and y2 based on your YH by rewrite it as a y1 plus b y2. So you know that your y1 is equals to cos x and your y2 is equals to sin x. Okay, for this case you cannot simply change your y1 and y2, okay, because this is your YH. Okay, only for case 1 where your m1 when you have two different roots, so you can either one can be your m1 and either one can be your m2. Okay, but for case 2 and case 3 strictly you have to refer to your general. Okay, since this one your m is in terms of complex root, so therefore this is your general solution for case 3. Okay, this is case 3. So your y1 is equals to, so the next step is to get the Euroscan function w. So you have to know your y1 and y2. So y1 is equals to cos x and your y2 is equals to sin x. So differentiate cos will give you negative sin, and differentiate sin will give you cos x. Okay, so therefore your w is equals to, so y1 y2, so you will have cos x sin x, y prime 1 y prime 2, so negative sin x cos x. Okay, so simply use this one, so you will have cos times by cos will give you cos squared x, minus minus plus sin squared x. So this one you can simplify by using trigonometric identity. Cos squared plus sin squared is equals to 1. So therefore your w is equals to 1. Don't worry about the trigonometric identity. Okay, we will give it will be given to you. Okay, so you don't have to memorize. Okay, so next step is for you to get your u. Next step is get your e and fx based on your differential equation. So your a is equals to 1, your fx is equals to secant x. And try to simplify this one. So secant x is equals to 1 over cos x. So use this one. Okay, I already gave this one in the previous video. Okay, this one, so refer to the previous video. So next we will find u and v. So your u is equals to, so negative integrate your y2. So what is your y2? Y2 is equals to sin x. Okay, your fx is equals to 1 over cos x, over your a is equals to 1, your w is equals to 1 dx. So if you simplify this one, you actually have to integrate sin x over cos x dx. Okay, so clearly you cannot integrate this one directly. You have to use technique of integration. When you involve with fraction, it's either substitution or partial fraction, but this is not a polynomial, so you cannot use partial fraction, so you are going to use substitution. So by letting u is equals to cos x, so du dx is equals to negative sin x. So dx as a subject will give you negative du over sin x. Okay, so substitute back into here, you will have negative, so sin x cos x is equals to u, so your dx is equals to negative du over sin x. So you can cancel out this one. So negative negative will give you positive, so actually you are going to integrate 1 over u du. So integrate 1 over u will give you ln u, which is equals to ln cos x. Okay, remember you cannot proceed with the integration if you still have the variable x here. So please make sure you already cancel all your x or use some modification so that you make sure your function is in terms of u du. Okay, so next your v. So your v is equals to integrate y1, your y1 is equals to cos x, your fx is equals to 1 over cos x, your a is equals to 1, your w is equals to 1 dx. So simplify this one. So actually you are going to integrate 1 with respect to dx. So therefore you will have x. Okay. So this is step 4. So since you already have your u, v and your y1 and y2, so you can find your yp, which is equals to u y1 plus v y2. So your yp is equals to, so your u, which is ln cos x, your y1 is equals to cos x plus vx, so your y2 is equals to sin x. Okay, so this one, be careful, you cannot simply multiply cos x by cos x. The cos x here is the argument for ln. Okay, so simplify this one will give you cos x ln cos x plus x sin x. Okay, so therefore you can write your general solution. Y is equals to yh plus yp, so you will have a cos x plus b sin x plus cos x ln cos x plus x sin x. So you will have the same answer. Okay, so we already discussed 3 examples. So I really hope that you can proceed with the example 4 on your own and make sure you get this one. Okay, and these are the exercise involved with variation of parameter. Okay, and this one is the example, so I will upload this in the module, so you may download it from there. Okay, so basically we are at the end of this chapter. Okay, before that, I will upload the checklist for this chapter 3, so go through one by one the checklist. Whether you wish subtopic that you don't understand, so please refer back to my video. Okay, so I shall see you in my next class with new chapter Laplace transform. Okay, thank you guys. So if you have any problem regarding the video or exercise, please feel free to WhatsApp me or uh, message me through Moodle or any apps that you have. Okay, so I will try to guide you. Okay, so thank you, stay safe, bye, assalamualaikum.